Welcome, everybody. We're going to be working on our last couple of apps here today. And you can see up on my screen, we are going to be working on first the rock, paper, scissors app, and then time permitting, hopefully we can also work on the meme maker and get these both done and working today before we go. That's ambitious, but we will give it the old college try, as they say. Let's flip directly over to that app here in the book. So they start talking here, and this is the teacher guide, by the way, that we have up on the screen. So I'm just showing you kind of the notes that I have available to me. Some of this is not available in your book if you have just the student version. But remember, the teacher version is available. It's not obscured. There's no mysterious information or answers in it per se. It's just auxiliary information that can be helpful. One thing that we're going to be doing here as we do the rock, paper, scissors is we're going to introduce you to this concept of what we call MVC style development, which stands for, as you can see on the screen, Model View Controller. And what this really is a way that we can basically take the portions of an app and separate pieces into separate components so they become standalone. And then as you do this, what we formally refer to it as is the separation of concerns. And the MVC approach is used in not just Swift, by the way, but most major programming languages have some way to employ this approach, especially when you build really complicated apps. This becomes a really logical way to kind of build them. The basic concept is this: when you build an app, you have one part of the app that really kind of runs the whole thing, and we call that the controller. So that's the one where most of the coding logic goes into that piece, right? You can think of it as kind of like maybe the main method in a Java program or something. It kind of steers everything. The other two pieces, the view, is the part that we put up on the screen, basically, that interacts with the user. And depending on what the user is doing, you might have different views. You might just have one view for your whole app, or you might have 10 or 20 or 50, who knows, right? But each one of those is a separate kind of screen that you put up and create. The model portion is where we take data structures of some sort. It could be a coding abstraction of what's in a database, or it could be maybe a struct or an enum or a collection of those things, or an object or class, or just maybe even a simple text file, but we write code that structures that information so it can be injected into the application, and we call that a model. It's not the actual data, mind you. It is the abstraction of the data that allows the code to interact with it. And that's kind of like a fuzzy concept here at this point, where you guys are at with your learning. But the MVC approach is really powerful, because that way, when you're building an app, you can kind of break things into pieces that make sense and build them individually, and then bring them all together to make them do pretty magical things. And then when you get into the controller and you write the code that steers everything, you're making very simplistic calls to the other components, like, hey, pull in this model of data and push it into this view, and then do this and that, for example. So MVC is a interesting approach for building apps. It is prevalent, as I'm going to say, especially in web-based apps that have a lot of user interaction in them. A lot of languages use it. So like if you learn, for example, ASP.NET and C#, it's very prevalent there. If you learn Ruby on Rails, that's what it's all about, by the way. That's how they operate. Java has frameworks for doing it, and just about every major language does. But in certain areas of development, it is much more prevalent. Mobile app development is one of those where it's super prevalent to use this approach. It just makes a lot of sense to do it that way. Now, we're going to be building this rock, paper, scissors app, and this is really kind of a real classic programming problem. So when I teach, for example, I don't do it in my Python class, but I know I do it in my Java 1 class when I teach it, that we go through this process of pseudocoding rock, paper, scissors, like coming up with the whole logic for it. Um, and then you learn to code it afterwards. But it's kind of one of these like studies in like um, branching and logic and if statements and else ifs and stuff like that, that kind of like gets watered down as you kind of keep going. What I find really fascinating about this very, very primitive game, right? And I want you to think about it like this, is if you like walk up to like a 5-year-old kid, right, and say, "Hey, let's play rock paper scissors," and they don't know how to play it, you can kind of explain how you play it to this 5-year-old, probably like in 2-3 minutes, and then get playing and you know see who wins. Right? It's not very difficult to explain, but I find that even such a very simple game, when you convert it to coding logic and start breaking down how you do it, all of a sudden it's like, oh wow, I didn't think about it that way. Like what's the actual logic that makes this work, right? And it's kind of interesting. So I have a lot of like pseudo coding stuff I could show you, and I really don't want to like waste the time on that right now. But suffice it to say that the logic at least is going to be sort of provided for us here, where we're not going to have to like figure that out. Normally, when I teach my Java class, I make the students figure it out, and it's kind of interesting because sometimes people come up with different ways to solve it, right? But generally it still has to work in the way that we expect, right? um, and then if you want to have fun with it, and I forget if it's like Big Bang Theory or something where it was like rock paper scissors Spock or something like that, you could
Yeah.
ramp up the game and throw that in if you want. And uh, I think in my last round of training, my instructor did that, whatever. It was just to have fun. But notice that we're going to be doing this with, you can see the screens, right, that are on up on the window right now, that um, we're going to basically have like representations of our hands, right, in the right mode. So the fist is rock, the flat hand is paper, and then the two fingers is scissors, right? And we're just going to stick with that, by the way. um, I'm assuming you guys know the basic rules of rock paper scissors, and maybe that's not really a safe assumption these days, but that was like a thing when we were kids, but we didn't have internet back then, so I don't know if kids still do this or not, but generally the approach is, people um, flash their hands and then choose one of the three symbols, and then depending on what they choose, there's an algorithm for winning, and the algorithm is basically the one that you see here. So two players face each other. On the count of three, they both make a sign at the exact same time with one hand. The sign is either rock, paper, or scissors, and then each sign can beat one and only one. So rock smashes scissors, scissors cuts paper, and paper covers rock. Okay. So I think probably you guys already know this, but I'm just saying it just in case. The other scenario that they're not really including here, well, no, actually they are, it's just not a bullet point, is the possibility that it can be a tie, right? And so what do you do in a tie? Well, you go again, right? And then, if you're the person who loses, then you usually go 2 out of 3, 3 out of 5, you know what I mean? Um, but what we're going to do here is we're going to simulate a two-person interaction by basically allowing the computer to randomly pick a choice, one of three, and then the user will pick on their own, right, manually, and then we'll see what happens. So all right, so you'll tap one of the three signs when the app is running. The app randomly chooses a responding sign, and then we see who won. And then hopefully you have screens that look like this. So this shouldn't take too long, but there's a bunch of little tiny takeaways from this, which are kind of interesting. The first thing is we are going to be building this in model view controller format. Don't freak out to that. I don't really want to get too deep into the concepts of it at this point. Just understand that we're doing that. So that's the approach we're using, because it just makes sense to do it that way. The first part of this, and you can see up on the screen there, it says the first part is creating the model, and that is basically the part that creates once again, an abstraction of the data that we're going to be interacting with. It's not the data, right? So like, it's just it's kind of like filling out a form in a sense. It's like setting up all the spots where the stuff's going to go, and then the data will come later, but that's the model for the data, is that form. So that's kind of step number one. All right, so what we're going to do is I'm going to move this over to screen number 2, right, which is actually screen number 1 for me, by the way. And we'll get Xcode fired up here. And the other thing that we want to do is we do want to get into our folder here. Yeah, see, I do not like this folder view for what I'm doing here.
Yeah, I didn't see a project for rock, paper, scissors.
Okay, so then you're answering. All right.
Is this wanting us to start from scratch, maybe?
Yeah, I think it is. And I guess maybe I should read the instructions would be the smart thing. Okay. Yeah, I'm just looking at the instructions. Okay. All right, so bear with me here a second. I'm going to pause the recording. I just want to make sure I'm doing the right thing before I get all silly here. All right, so I have confirmed that they don't have like a previous component that they want us to load up. We are building this completely from scratch. So with Xcode up and running, and here comes my splash screen, we are going to create a new Xcode project. We are targeting this for iOS, and it's an app.
Don't mean to interject.
Yes, go ahead.
Did you try using the search function? Because I used search function and I found rock, paper, scissors.
Where did you find it exactly, Jomar?
I used Spotlight.
No, I mean, but where was the location of the file?
Oh, yeah, 1 second.
You might be looking at a teacher version, which is complete.
C folder. Let's see.
Yeah, and now that I'm thinking about this,
it is in the teacher folder. Yep.
Oh, it is.
Yeah, it is in the teacher folder. Yep.
Oh,
well, the teacher folder includes the completed versions of the apps, by the way.
Okay.
So, yeah, and just a really helpful hint, like, if we do not finish the second app today, and you guys want to finish it, just for your own sake, you can look at the teacher. I would follow the teacher's guide to build it, and then you could also look at the teacher's version to see what you're doing right or wrong, right? Okay. That will be the completed version, though, and sometimes as you do, the incremental steps are not the same as the finished version, which I think you guys have already seen. All right, so we are building this from scratch. We are going to name it. I'm going to name mine RPS. Language is Swift. We're using a storyboard. No core data or include tests. All right. And then let's just follow through with this and get a location for where we're storing it. That location is fine. And then we have the info screen here. Tells us all about the app. So now that we've gotten to that point, what we're going to do is we're going to go ahead and over here on the right side where the RPS folder is, we're going to go ahead and either right click or control click if you have that set up. And then we're going to make a new file. Okay. And we're going to choose Swift as the file. Go ahead and click next. And they want us to name it Sign, S-I-G-N. Remember, the file extension will be automatically added, so you don't have to add .swift after it. And it says, make sure that the group is set to the Manila RPS folder that you created. And I don't remember creating one, but it looks like it's pointing to the right spot, so I'm just going to go with it. All right, so that's where it's going. They do have a graphic of this, so I'm just kind of double checking the graphic, and it looks like we're okay. All right, so go ahead and click create. And what we're creating, this is kind of the first time we're actually doing this, which is kind of interesting, is we're creating a blank Swift file that we're going to add into our project. The goal of this file is to hold an enum that's going to hold information for the app. So we're going to create an enum with cases representing each sign. So in other words, rock, paper, scissors. And of course, you can always name things any way you want. So if you wanted to make a variant of this game and whatever, you could totally do that. And we did name this enum sign. All right, so let's go through the process of creating the enum and see if we even remember how to do this. I don't know if you guys remember the procedure for this. And I'm going to pause here for just a moment. All right, so we want to call this enum. We want to call it sign. Curlies. And then inside here, I mean, we have three different things that we can be: rock, paper, or scissors. I'm just going to create case rock, case paper, case scissors, just like that. If you're curious about this other stuff here at the top, well, there's these comments. So if you want to, say something up there, like put your name in there, feel free. I'm going to do just the opposite and get rid of it. We are going to keep foundation in here just in case it's necessary, but these are kind of like the foundational libraries basically of Swift, and typically we just leave those alone. We will likely have to add stuff to this as we go, but for right now, this is all we're being asked to do, is just to basically create these cases. All right. The other thing that it's asking us to do, and I guess, it's happening faster than I thought it was, is we want to add a computed property to give the emoji that represents the sign. So what we want to do is inside the enum, we want to basically add structure. And we're in the habit when working with Swift of always doing lets, right? Because those are constants, they operate faster. But this is going to actually be a variable. So we're just going to say var, and then we're going to say emoji, which is going to be a string. Of course, emojis are strings. And what we're going to do here is we're going to put in a switch case statement that is going to look at whatever the object is itself that's referring to this. And I know that's kind of like sketchy terminology, but basically an enum is really kind of a structure that is going to basically give you the data that you need to create something. And we will basically extract that data from this. When we're extracting from it, we will look at snippets of text and then convert that into an emoji, and that's going to be relative to whatever the user taps on the screen, right? So what we're going to do here is what we're switching on, normally you'd have like a variable of some sort, but we're going to switch to self, which means it's self-referring back to the object that's being sent in here. Don't worry about the conception of that too much. just trust that it works at this point. We're gonna have 3 cases here. One's gonna be rock, and notice how I do the dot rock on this. And then when we send that in, we are gonna return an emoji. And this is where you bring up your little emoji panel. So if you don't remember how to do this, on most of the modern Macs, if you hit the function key, you should be able to bring up that emoji panel. It is possible in your settings, though, that you may have overridden this command, so then you have to go to your keyboard settings and re-enable the function key, triggering the emoji panel. What we're looking for here is a fist, right? So there's my fist. That'll be rock. If you like a different skin tone, go for it. I'm just going to go with the default. All right, so there it is. And then we're going to do the same with paper and the same with scissors, but we're doing the hand representations, so I don't want like a literal piece of paper or literal scissors. Although, you know what, I suppose you could do that if you wanted. There's no real rule here, but this is the way I'm doing it. So paper, and we will return, and then once again the emoji panel, and I'm just going to type hand, and hopefully I find the right hand. I think this is the one that they used. Right, and here's your little Spock symbol right there too in the emoji panel. I just think that's fantastic. All right, there's the hand, and let's do case dot scissors, and then that will be. And I'm going to search for peace sign. I don't know if that is. There you go. That's what that used to be. Right. Actually, it used to be victory, and then it became peace, right? How the world has changed, folks. How the world has changed. All right, so there we go. So here's a computed property. So in other words, if we reach in here and we ask for, what, the symbol is, it will return the correct thing. Right, so we added our computed property that represents the sign. All right. So now, as we kind of get started here, I'm going to pull the book back over to the screen here for a moment, because they have some interesting information about how we would proceed. So this is one of the reasons why I didn't want to go into like the flow charting too, is they have this little chart to help you kind of negotiate your way through this. All right, so it's saying that we have 4 different states the game can be in. Start, which is right when you load it up, just waiting for you to tap. Then either you've won, right, and you get a win message, or you lose and you get a lose message, or you draw and I guess you get a draw message, right? And then we have to basically create another file here to hold an enum with the 4 cases as we've named it above. So in other words, so start, win, lose, and draw, and that's going to be in a brand new enum. And then the situation becomes, where do we put that? And it's not going to be in the same file that we already have going. So we have to create a new Swift file here. So let's go back and let's get this out of the way, by the way. So another new Swift file. So I'm doing it the same way. I'm right clicking the gray folder. I'm saying new file. It's a Swift file. And we're going to name this game state. Let's go ahead and click create. Same thing. We're going to leave foundation there. We're going to go ahead and create an enum. And as you guys have learned before, the convention is you name the file and the enum the same name, right? That's a logical thing in terms of executing the code. So now we need to basically figure out what to put inside there. And yes, I'm doing a little cheating here. I'm opening this up on my other screen, so I make sure I don't omit something. But the 4 cases that we have are case start, case win, case lose, case draw. Now you could, there's shortened syntax ways where you could all clear them all at once. That you can do that too if you wish. So the next thing it says is you need to be able to compare the 2 sign instances to give a game state. For example, a player's rock in a computer's paper would give you a lose for the player, right? So we have to add an instance method that we're going to add not here, but to the other file that we have, which is signed still up on tab here. So we're going to create an instance method here that representing the opponent's turn as a parameter. And it says the method should return a game state based on the comparison between self and the opponent's turn. And it says there are many ways you could write this function, right? So this is kind of one of these exercises where normally if I was doing a regular programming class, we would pseudocode the whole thing first, right? The whole logic of the whole game. So it says you may want to work in a playground first so you can check the possible combination and give the correct results. We don't have that kind of time. It's the end of the semester, so we're not going to spend that time doing it. But what we are going to do is we're going to look at something that's kind of pre-built here, and I'm going to recreate it basically with code. I'm going to try to do it as fast as I can for the sake of time efficiency here. So what we're going to create then is we're creating a function called game state. We are going to put in this, I forget what they call this. This is like the virtual name coming in, and then the next one is the one that's used inside the function itself, or the method, really, truly. And that's what we're sending in. So we're sending in, what are we sending in? A sign. So in other words, rock, paper, or scissors is what we're sending in. And then what it's going to return is a thing we call game state, which of course correlates with the other enum that we just created. So isn't that kind of interesting? So we're feeding in, basically an enum state, and then we are returning an enum. I think it's kind of interesting. So the first part of this that we're going to put in, we're going to say if self is equivalent to the opponent sign. So in other words, if it's a draw, what we're saying here, return the value dot draw. Okay. And I think this is an important one to put in first, right? Because there's no win-lose, in that situation. Next, we're going to create a switch statement for the rest of it. And once again, we're self-referring to whatever object is being passed in here. And then we're going to set up the case of .rock. And then here, what we'll do is, if it's rock, then we're going to check and see if the opponent sign equals .scissors, we will return .win, right? So think about that. If we put in a rock, the opponent puts in a scissors, we win, right? That's how it works. Okay, so that's really the logic we're recreating here, if you're just kind of wondering what the approach is. Then we're going to do another case for paper, same situation, and we'll say if the opponent sign equals rock, then return that win. And I want you to look, this is kind of an interesting logic approach, because they're only setting up these for winning scenarios, because if you don't win, it doesn't matter how you lost, but you lost, right? So they're only checking for the win. And it's a clever approach. And I think intuitively what a lot of people would do is they would code both the win and the lose situation at the same time, which isn't logical, right? So basically, this is kind of a shortcut way to write this code, because we're only looking for the win, and if you lost, who cares what the losing scenario is, you know? But we do need to also have a situation here where we return dot lose at the end. So if none of the winning scenarios hit, right, then lose is returned automatically. So it's either going to be a draw, or it's going to be one of the 3 wins, or it's a lose. Now, if you really like do a matrix of this and figure out how many possibilities there are, I think the matrix works out to, I think, 6 possible combinations, or 7, something like that, you know, or maybe it's actually 9 now that I think about it. Yeah, I think it's 9 possible situations. It's a permutation of 3, and then the possibility that you could tie, right? So whatever. All right, so this happens. Oh, I see. I forgot my curly bracket up here. It's a good thing I looked, right? It's ready. Switch files. Should resolve the error. So then let me make this a little bigger up on the screen here. All right, so there's the current state of the code for the sign file.
I'm actually getting an error.
Okay.
Same.
Missing return an instance method expected to return game state.
Yeah, and right, did you include the return lose at the bottom
I did, yes.
outside of the switch statement?
It should be, oh, it's not outside of the
Yeah,
switch self.
yeah, so it should be
Okay.
and you know what, that's really a good point. Yeah, I made the
Okay,
same
there it goes
mistake,
away.
by the way. I put it in the wrong spot, so you were following me and failed miserably, basically.
Yeah, when I put it outside of the switch self, the error went away.
Yeah, it should. And I'm just double checking on my curly brackets here. So this one, okay, these are pretty self-evident. This one goes with that one.
If you double click it, it'll highlight the entire block.
Yeah, I'm just right. So that's good. But then what's happening is I'm missing one curly bracket here at the end, I think, is what's going on. Right.
Oh, for sign.
Yeah.
Yep.
Yeah. I just need one additional one at the end. There we go. And see how that like restructured it correctly then.
Yeah.
All right, so now we're okay. Okay, so now the error should ideally go away. All right, so that's the first thing. Now the next step on this one is now we have to generate a random sign. So in other words, we need a way to do that. So in other words, so that the computer doesn't see what you guess and then automatically chooses the thing that wins, right? That would be a cheating way to win. You know, so what you could do is it says hand code an array of arbitrary values, and your app might look random at first glance, but it would soon notice that it repeats the same sequence every time it runs. So we don't want to do that. So there is a way to generate a random value within a range. And basically the way that it works is that the random number generator, you declare a range of integers between one number and another, right? usually starting with 0, by the way. So what we're going to do is we're going to write a function inside of here, and where I'm going to place mine is all the way up at the top. If you're wondering the why, it's because I'm copying an example, and that's where they have it, right? So it's outside the enum structure, but it's inside the sign. And so what's going to happen here is this sign file is going to handle who wins and loses, right? Sets the emoji, and also generates the random value of the computer picking. And so we're going to create another function here to do that. So we're just going to call a func. We're going to call it random sign. And that's going to return a sign, which is our enum, which is internal here. Here's my curlies for it. Then we're going to set up a constant. We're going to say lowercase sign. Let's sign equal. And here's the random number generation. First of all, we're generating a random integer. And so we're going to say int.random. And we're going to take that first option there in. And now we're going to declare a range. And we're just simply going to say 0 dot dot 2. And so it just basically says every time you hit this statement, generate a random number. And since it's an integer, it's going to be 0, 1, or 2, 3 possible states. Right. So that's going to happen. Then after it generates the value, we're going to run an if statement to check it. So we're going to say if sign is equivalent to 0, one of the 3 possible options. And this is flagging an error here for me. You guys getting an error? Oh, yeah. I only put in 2 dots. You're supposed to put in 3. Okay. And I apologize. That's a hangover from a different language, by the way. That happens a lot to me because I'm always teaching different languages,
It's one of my biggest habits I'm finding out is I'm accidentally putting semicolons after everything. I'm just like, oh my, no. And then I go into Java and then I don't put semicolons.
Right.
And I'm just like, oh my God.
Yeah, right now, if I listed all the languages I was teaching simultaneously, it'd probably make your head spin, but you guys get in the same boat the whole time for sure.
Yeah.
All right, so this first one, we say if sign is equivalent to 0, we return rock, and then we'll do else if. And we're going to say sign equals 1, then that will return paper. And then one more, we'll just do an else because it's got to be one of the 3, right?
So you got two there.
All right, so yeah, right. One should be the next number. And then otherwise it's gonna be 2, right? That's the only possibility there.
Mm-hmm.
And did I miss my curly bracket? Yep, I sure did. And this is pretty intuitive. Return dot scissors. So it's either going to be 0, 1, or 2. We got all 3 scenarios covered. And that would be the random sign function. And believe it or not, with all of that work, this file should be complete at this point. So, all right. If you're following along in the teacher guide, we're now moving on to page 586, where they actually showed the code. So I didn't have to copy it from the teacher file, but I did anyhow. But there's an example of the code. I haven't tried a lot of copy and pasting right from the book, but I think what I've discovered is when I do copy paste, it brings a lot of artifacts that make citations for the book. And that's why the teacher files are helpful, by the way, because that way you can bypass that if you don't want to do the typing. There's nothing wrong with typing it in, though. There's builds character, I think. All right. The next thing that we're going to do is, okay, so if you want to think about this, by the way, this sign file is really kind of the model for our data in a sense. and it does a lot more than just model the data. So like creates and gives us the three possibilities of rock, paper, and scissors. It also allows the computer to randomly pick one of the three. It also determines who the winner is, and it also sets the emoji relative to the rock, paper, scissors. So not only does it define the data, but because enums can have capabilities, computed properties and instance methods, it all travels with. So I think that's really kind of interesting. And we would still call this a model of the data. Now we're going to move on to the view, and we're going to switch over to the main storyboard at this point. And so there comes the main storyboard. And then it says click on the devices icon at the bottom and then choose whatever phone you're propagating to, right? And that should be the same, but just in case it may be reset, just be mindful of that, right? And it says drag a button from the object library onto the scene and change the button's title to fist, right? All right, so this is kind of weird. So these are very concise instructions. So we're going to follow these. So we're going to drag a button onto the scene, and I'm just going to kind of put it here. We can move these, keep in mind. Right, so there's the button. And then we're going to go to the title here, wherever it's, oh, right here, right? And now we're going to hit your emoji panel and put in this. Now, I don't know if you guys noticed this, but if you use a lot of emojis often, apparently they're like bees, tacos, and dinosaurs. Just shows the kind of work I've been doing on here. I'm just gonna go ahead and choose fist. And it says set the system font size to 70. And I'm trying to find the system font size. Am I just blind here?
No, I can't find it
I
either.
can't find it.
Oh,
either.
it's right here. It's right below.
Oh, it's dumb.
Oh,
Yeah, that yeah, agreed. This is no font, right? Because we have an emoji. But here we're going to set this to 70.0. And basically what that's going to do is make it bigger, right? So instead of a tiny little fist, and it's still not applying it. Not sure why that's not taking. Is yours working, you guys?
No.
So I don't know if this is a good fix for it, but I did switch the font to system. Right now it's at plain. So if you bring up, no, it's not that. If you click up that T box there, where we try to adjust the font size. Yep, right there.
Yep,
And then
yep.
font system.
And it does say right in the book, set the font size to system 70. And system is bold. I just didn't read it. So there you go. There you go. That's more like it. So that's a fist of note. All right. All right. So now we're going to duplicate the button twice. Do you guys remember how to do the duplicating?
I want to say it's
Oh, man.
control.
Is it Command D?
Yeah, Command D.
Oh.
And we're going to replicate it twice. And then I'm going to spread them out like this. And you know what? I may highlight all three and just move them down a little bit, something like that. Maybe right in the middle. That's good. Set the titles to the correct emoji. And So let's do that. So we'll keep the first one as fist. The second one can be paper, right? So we want to switch that emoji. So let's go ahead. I'm hitting my emoji panel here. This would be the symbol for paper. And it should change once you flip out of that field. And then this one will be changed to scissors. And there we go. So we got rock, paper, and scissors. Yeah. And I think probably having these in the center of the whole thing seems to make sense, and that's what the book is saying. To assure they're aligned vertically, you can use the guides, and I think you guys probably get that part of it. That's pretty intuitive. But I like their layout right now. Okay, it says drag in another button underneath the 3 hand sign buttons. This will be the play again button. So let's do that. So this will be the play again button. Set its font. Read this. To title 1. So the font here, we're going to choose. Oh, there's no.
It's under font. So if you click that again, the same way we set it in the system.
Yeah.
There we
There
go.
we go. All right. So title 1. And I think we want to change the text on there to play again. Now it's asking us, and it's really kind of interesting how you get to this app build. They really don't give a lot of examples. It's just a lot of very direct instructions and a very minimal amount of pages. I'm just kind of reading right from the instructions. And it says, drag in a label above the 3 hand sign buttons. This will tell the users what's happening in the game. Make it the full width of the view and choose title 1 for the font. All right, so this is an object we haven't added to an app yet, but a label is basically a thing that we can use to put text in, right? And change the text that the user cannot change, right? It's this text that we control. And they want us to drag this in above the hands, and then they want us to set that to another title 1, and then make it so that it goes margin to margin here. I think it's kind of their goal. So I'm just rereading the instruction. Make it the full width of the view and then choose title 1 for the font, right? So this is where our message is going to be. You could also center it. And I think I'm going to do that because I think that'll probably look better. They say nothing here about that though, by the way. All right. It says drag in another label above everything else. So let's go to the library again. And now we're pulling in another label. And we'll put it somewhere around here. I'm looking at their little example screen too, is like where they're placing stuff. And it looks like this label is probably a little bit higher, something like that. And then they have this new label that we just added. The font of this label should be the same font as used for the emoji buttons. Both labels should be center line text. Right, we did that with the other label. Here's this one. And the final scene should look kind of like this. All right, so when they say the same font as the emoji buttons, that means that we do, right now it's at 17, we want to go to 70. So we want to make that big, right? Now, why so big? Because this is where the computer's choice is going to drop in, right? So in other words, this is going to turn into an emoji, right? That shows the computer's random choice. And then this is going to display where we're putting, our win-loss messages, I believe. So I'm just kind of doing a little bit of arrowing about here to kind of just smooth it out a little bit. All right, I think that's pretty good right there. So hopefully kind of looks like this so far. Next thing that we want to do is we do want to, it says show the assistant editor and then create outlets so that you can update the screen during play. And, you know, before the last few times we did this, we had very detailed step-by-step instructions for creating outlets. And now it's like, just do it, right? It's kind of the approach. And so, wish us all luck here for sure. And now normally when we do that, we're going to open this up in a new tab, right? So here's the view controller, but then we also want to split the screen. And so I'm moving the view controller over and then going to get that storyboard on the other screen. You might want to expand your width here a little bit to maximize your space. And of course, with the storyboard, you know, the way it is, you can make little tweaks to make it a little more comfortable space-wise. I think that's not a bad idea. I'm also gonna, I like to make the code window, you know, generally as big as I can. If you want, of course, you could, and I'm trying to move this over. My magic mouse is not cooperating right now. So much for the magic. Right, you could close the side panel as well, but I just put it here. So, all right, so the things that need outlets are going to be the topmost label, the second label, one for each of the sign buttons, and one for the play again button. Now, before we do this, I'm going to pause for just a second. All right, so what I'm trying to add in here, and I did have to look at, like, you know, a previous version of my code to make sure I'm doing it right. It's one of our instructors, when I was going through the training, told me that because when you're creating an app like this, it's really common to create certain parts of the application over and over again. So for example, like creating outlets or instance properties or view did load or etc. And it's helpful if you want to organize your code to put in what we call marks in the form of comments, but it helps to kind of organize things so you can see stuff really quickly. So I'm going to just very quickly here, inside the view controller file, I'm going to create some markings or basically comments that help to kind of organize our code. And the syntax kind of goes like this. So you do 2 forward slashes, mark all uppercase with a colon, and then we call it IB outlets, right? So all the outlets will go here. Yeah, spell it correctly though. The other section we're going to create is mark instance properties. Another common thing to do is to mark your view did load. Then I'm going to drop down before the view did load here. And I'm going to do a mark for IB actions. Another mark here for instance methods. And this is just an organizational technique because these are the kind of common things that we do. But it also helps, you know, to organize your code. And, you know, so if you're looking for your outlets, you don't want them all over the code file. You know, it helps to have them all in one spot and to be able to organize them. So if you guys want to add these in, these aren't required, by the way. These are just helpful additions. It's really kind of a good way to say it. All right. Now, normally, you know, you might like kind of switch this stuff around. You could put it in different spots. There's no real precise, correct way to do this. But I'm just looking at an example that I had, and that's how it was organized. So that's what I'm kind of pushing to you guys. All right, so let's go ahead and do the process now of making those connections. And do you guys remember what key we press to create the outlets? Right?
Was it
it
control
shift?
click?
Yeah, it's a control drag, right?
Control click drag. Yeah.
Yeah.
There we go.
Yeah. All right. So what we're going to do is we're just going to march right down the screen with all of these visual objects and create outlets for them. So here goes. Here comes the label. I thought I clicked. There we go. That goes. And now what I'm looking for is what I should possibly name these. And so if you can just bear with me here. And the reason I want to be really consistent with how I name this is so that we're not basically all using different names and then wondering why it's not working.
Yeah.
So once again, I'm looking at an example here that I've done before. Okay, so the first one we're going to call sign label, and that's where the computer's choice is going to drop in. And that's an outlet. UI label weak, that's all good. So we're going to say connect. Go to the next label. We're going to control drag over again. This one we're going to call status label. Another thing I feel kind of compelled to talk about here, because we're kind of working with this GUI approach, and what's really common in GUI programming, regardless of what language you're using, is there's conventions in every language for whenever you name an object that you also include what type of object it is in the naming of it, so that when you look at it later and you're looking at a piece of code, it's like, is this a label or a field or a button? Oh no, it's right. It says right there, status label, right? So you know what object you're dealing with. So what Swift does it by kind of naming it and putting it at the end. When we work in other languages, and I think of Java a lot because I do a lot of GUI stuff in Java, the convention in Java and, real frankly in Visual Studio too, is to use the object type as the preface for the name. So for example, if I was creating a button, I might say BTN play again. For example, we're going to kind of flip that and we're going to call it play again button. But either way, the name is kind of embedded in there, so you know what object you're dealing with. That's the grand takeaway. We're going to just keep proceeding here. The next one is going to be rock button. I'm going to create a little space here for us to work. If you're really methodical and careful, and I think at this point we've kind of learned to be that, right? It should be a relatively repetitive process. And then finally, we have, not finally, scissors. We have two more, not one more. So this is the scissors button. Finally, the play again button. Notice the camel casing on the naming, by the way. And we are connected. The other thing I'm going to do is, we got a lot of these now, more than we've had before. So I'm going to kind of condense down the code here just so it's a little easier to read. This is not obligatory, right? This is just a preference on my part to kind of condense things down. I don't like to waste screen space, especially when I'm teaching, because that way you guys can see much more easily what I'm doing. I'm also going to kind of get rid of this blank line here. So nice and concise little listing of outlets. Now, interestingly, I don't think we're going to be placing anything in instance properties, but it's possible that you might have something, right, that might go there. I'm just going to put a little note here. probably won't get used. In fact, I know pretty certainly it won't, but I'm just telling you right now. The other thing I want you to notice that's kind of interesting is you notice that when I put the marks in here, how those are bolded and how the comment I just added is not. And that shows you that it's indicative of a special type of comment. The same is true, by the way, in like C# and Java, you can put in notations like this too. Part of it is it allows you in certain environments to kind of like not only find your stuff and organize it, but also kind of to collapse the code down and expand it and organize it a little bit better. Now, the next thing that we have to do is we do have to create the actions to handle the button taps. So one for each player button for rock, paper, and scissors, and then one for the play again button. And these are going to go in the actions area. Now, because the last time we did this, real frankly, we I think we put this stuff way up at the top, if you recall, and I'm kind of tempted to move it up there, but I'm not going to. I don't know if you guys are also noticing now that the marks are fully in place. It's really, really subtle. So I don't know if it's coming through on the screen recording or the screen share. There's a really subtle light gray line in the mark sections, right? All right, so I'm going to go ahead and add a little bit of code here. And if you guys remember, the way that we do this once again is we're going to control drag into the action section from each one of these. Now, as I do this, right? Oh, that was the wrong key. I was command dragging, not control dragging, not good. And do you notice that as I'm kind of moving around here and I'm not letting go, right? So like if I want to take it to like any particular spot and it kind of like chooses spots for me, it is also intelligently picking up the fact that it's an action now, right? Which is good. And what we're going to name these, I'm going to call mine rock chosen. So in other words, when they hit this, you're choosing a rock. We're going to leave the type as any. And I think just generally speaking, we're probably just going to leave that exactly as it is. I don't think we need to make any changes to the connection at all. But, if I do it wrong, I guess we'll figure that out and fix it. So let's go ahead and, yeah, that is the correct format. So, yeah, so any will work. We're going to do the same for the others. So let's just do those one at a time. So control drag, make sure you don't land inside those curly brackets. So we got rock chosen, paper chosen, control drag, scissors chosen, and then finally we need the play again button. So there's a control drag for that. I'm just going to call that one play again. All right, and there we go. So it's creating a little space there. So make sure your code looks like this. So we have a bunch of outlets created and now a bunch of actions created. Now we got a bunch of additional work to do here, and I'm not sure where they're going to tell us to connect all this. So I'm kind of looking at the book instructions here really carefully. All right. They don't want us to add anything inside there, but we will in just a little bit add some tapping commands, by the way. All right. Looking at the clock, I think we should take a break. We've been going for a bit without stopping. So let's come back in 5 minutes.
Okay.
I'll pause the recording here. All right, folks. So we're now moving on to part 3 of the app build. So if you're following along in the teacher's edition, I'm on page 590. And so far, we've created a couple of enum files and whatever, and we just went through the process in our controller file of adding outlets and actions for all of the interactive components on the screen. The next thing that we're going to do is we're going to start updating the user interface using the code and the view controller to kind of control it. So when you think about this whole MVC thing, the view controller is the controller file for the app, right? And what we're seeing on our screen with the storyboard is one of our views, right? And then, of course, the sign and the game state are basically model files. So we're really kind of employing that approach, even if you don't know a lot about it yet, right? But just to show you that you're actually using it. So now you can tell somebody, hey, I've done a little MVC programming. Very little, but I've done some, right? Or at least been introduced to it. All right, so our goal here for updating the interface is basically, so when the game changes from what we call one game state to another, we have to update the UI. So for just like do an imagination here, you start the game, you tap like rock, paper, scissors, one of the three hand gestures, the computer responds. There's either a winner, a loser, or a draw. Then you have the option to play again, but we have to update the screen when something happens so the person knows that something happens who's playing the game. All right, so we're going to add a method here to the user interface to do an update, and the method should do the following thing. So it says it should set the status labels text property to an appropriate message, and then you want to think about this here. It says, should the text you use be a computed property on the game state enum or a string literal inside the method that you're writing, right? So that's kind of an interesting thing. So we're also going to set a different background color to the main view depending on the state. And so in other words, if you like win, it's green, for example, that kind of thing. If the game is in the start state, do the following. So it gives us a whole list of stuff to do. And really what they're doing is they're giving us a pretty complicated set of instructions here. I'm going to try to pop through this as fast as I can. So I have an example file here on my screen that I'm going to borrow from. I may even trigger my copy pasting mode here to really accelerate things. And if I start doing that, because I am under a tad bit of a time crunch, because I was just telling Jomar, somebody threw me into a meeting here, actually my boss. So kind of one ideally I probably should go to. And I'm just going to do that to kind of accelerate things just for everybody's sake here.
Sure.
So, all right, so here goes. So we are going to now in the, I'm just trying to see which section. This should go in the instance method. So we're going to add this way down here at the bottom. So this is going to update the game state for us. And we're going to call this function play. What we're going to feed in here is the user sign. So whatever the user selected on the screen, of course, that's in the format of our enum sign. Here's my curly brackets. And then we're going to throw in a couple of constants. So the first one is let computer sign equal random sign. Now keep in mind, this is pulling this random sign thing from here, right? So this is what we're actually calling it. It's not like magically appearing from nowhere. That's something that we created. So it's triggering that function which lets the computer pick. So like when you play the game, we're letting the computer pick a sign and we're storing it, right? Then we're also going to set the game state. So we're going to say let game state equal whatever the user sign is. And then we're going to trigger the game state method within it. And what are we doing? So the user sign is going against what? It's going to go against the computer sign. Right. And look at the syntax in that. I think it's kind of clever. And this is why you have this kind of like Swifty kind of syntax. So the game state will be equal to the user sign against the computer sign. You know, so that's basically determine, you know, like who's winning and who's losing here. Now, based upon that, we will do an update to user interface. And this is something we haven't created yet. So this is where it kind of gets a little bit weird. So we're going to actually create this very systematically, one at a time. So in other words, I'm gonna do the function call here before I've actually created the function, and then I'm gonna go create the function to populate it. Right. But basically what I'm going to do is I'm going to create another function called update the user interface. And I want to spell that correctly, right? So we're going to create a function called update the user interface. And what we're going to feed into it is the current game state. And then that update user interface will be what changes the screen every time there's a win or a loss, right? That's just going to change what happens on the screen. All right. So right now it's saying it can't find it in scope. So let's go ahead and create that really quick. So what I'm going to do is I'm actually going to create that function above this one. So I'm going to call it func update UI, and then set of parens here. But let's work inside the parens here for a second. So we're going to use the for state as our external variable or constant name, and then it's going to be of type game. That's, yeah, it's going to be a capital G game state. And I think we're good there. Now we need a set of curly brackets, and then we're just going to start adding stuff in here incrementally. So this is kind of interesting because we're going to be at this point treating the objects on the screen and addressing their properties directly. So the first thing is we have a status label, and the text inside that status label will be equivalent to the state of the status. All right, so this is kind of weird, but basically what's happening is we're pulling that in from these external files, and you can see I can't even see them all here anymore, but if I just move that over, it comes from the game state file. That's where that all is connecting up from. So all right, so here I did misspell status. You know, that's the underline, so it should be lowercase. The other thing I do want to check here is, now if we're going to be updating the status from the game, we're going to need a message in the game state file to do that for us. Now what I'm going to do is to save time here is I'm dropping this code in the chat. So this is my holiday gift to you guys, I guess. So I want you to add that code to your game state enum. So you can see me doing it here. So I'm just pasting it in directly just to save time. And so in other words, we're going to check the game state status relative to what the game state is. So whether it's start, win, lose, or draw. Start will be what happens when the game fires up. Win if you win, lose if you lose, draw if you draw. And this is the text that will then appear in the status label, or in other words, in this field right here. And then we're setting it through this code. That should update at this point. Yep, it did. Okay, so that error message went away. And now let's keep adding some code here. So that was the first aspect of this. Now we're going to go into, you know, depending on that status or that state, if you will, we're going to structure a switch statement. And I'll just begin the switch statement. So I'll say switch based on the state, curlies, and then we think of the four cases once again. So we will have basically case dot start. I'm not worried about typing code in here yet. I'm just going to create the four cases. State dot win case, lose case, draw. Now I'm set up to drop in code. Now I'm gonna do this in kind of a rapid fire fashion here just to kind of get the points across. But the first thing I'm going to drop in for the start one is when the app starts, the first thing that we're going to do is we're going to change the background color to gray. So we're just going to type view.background color equals .gray. The next thing that we want to do is we want to apply, and I really don't know how this is going to, I'm going to paste this in the chat. This would be really interesting to see if Zoom can handle this. How it does. It takes the robot emoji just fine. But the next thing that we're going to do when we start the game is we're going to set the sign label, the one up at the top, the big one, to be a robot face, like you saw in the initial screens. And the play again button will be hidden at this point. So the is hidden property will be true, because you can't play again if you never played in the first place, right? So we're, when the game starts, we're hiding the play again button, right? So that's one of those weird situations where it's like, hey, when do you ever hide something in a program? Well, here's an example, right? Now we're going to kind of set up all the little scenarios here for the rock, paper, scissors buttons, whether they are visible or not, and then if they're enabled or not. So we're going to do this in kind of two fell swoops. So I'm going to give you all the code at once, and you can just paste it in. So once again, in the chat, here it comes in the program. And then I'll kind of walk through the logic of this a little bit as I clean up my code. So when it starts, the rock, paper, scissors buttons, the is hidden property is false, meaning they're not hidden. We can see them, right? So that's what that means, right? To make sure they're visible. The other thing that we're doing is we're making sure they're enabled so you can tap them. You know, that case, that's basically what's going to initiate the game. So whenever the game starts, we're going to set the background color to gray, put the robot emoji up at the top, hide the play again button, make sure the rock, paper, scissors buttons are visible and active. That's what we're doing here. Right. Now, the reason you might, ask about like the process of this, but remember, we're in like hurry up mode here. It's kind of like, we got 2 minutes left in the game, no timeouts or something. So we're just trying to go as fast as we can. All right. Now, in the win scenario, we didn't get a lot of directives here, but basically the primary directive was to basically change the background color to something to indicate a win, right? We're also going to put like a message on the screen, but we're going to change the background color. So, so for a win, here's the one for win in the chat. So we are choosing very specific values here. These are values from the author's solution, by the way. You don't have to use these colors if you don't like them. For lose, you want to use this one. It's on my screen. And then for draw, and of course, we won't see what these colors are until afterwards because they're being declared as RGBs and floating point values, which gives you a lot of precision, by the way, but we're not really seeing what they're like, in this circumstance.
Can you post the draw in chat?
Yes, sorry.
No, thank you.
All right, I forgot. I was breaking my pattern there. All right, so that is the complete update UI function that we were calling from down here, right? So there's the whole thing. And I'm going to try to condense my code down here just a little bit, partially to kind of, and normally I would keep these things kind of like spaces in between, but because I want to show as much as I can here on the screen at once, I'm going to condense it down like so. All right, so now you can see it all and I can keep coding. So now we're going to pick up down here where we left off. So we handled that part of it. Now the next step is we need to take the sign label, that's the big one up top, and it's text. And what we're going to set it to is the computer sign dot emoji. So in other words, the game is playing, the computer picked one, we're taking that emoji and we're putting it up at the top in the big label so we can see what they picked, you know, because they picked rock, paper, or scissors also. And then this logic that we used up here with is hidden and is enabled is all going to flip now. So I'm just going to come up here to this function and grab all of that. So we're grabbing all the is hidden, right? And actually I got to be careful on that. I don't want the play again button. We want rock, paper, scissors is hidden. Rock, paper, scissors is enabled. All of those, just grab them as is. And then we're going to flip the state on all of those. So here comes the flip. So these will become true. And if it's easier for you to do copy paste, do it like that. So now we're hiding the buttons because we already made the choice. And then are the buttons enabled? And here we will say false. And then, of course, I would recommend a copy paste here as well, just to make it go as fast as possible. Right. So we made our choices, hide the buttons so you can't play again, and then they're not enabled anyhow. So even if they were visible, you wouldn't be able to see it or wouldn't be able to do anything. Now what we're going to do is we're going to check what we selected and then switch whether or not that should be visible or not. So then we can compare. So for example, if I hit rock, I do want it to be visible so I can compare my rock to the paper or scissors that the computer picked. And so we're going to do that with a really quick switch statement. Once again, in the chat. Of course, if anybody watches this video on YouTube, you're like, hey, can I have the code in the chat? Nope, you can't. Sorry.
Pause the playback.
Yeah, you got to type it in. You know, that's part of the price of admission or something. And normally the format should look like this. So my pasting wasn't very beautiful, but a lot easier than typing the code. So this will just look at whatever the user chose and make sure that icon was visible, even though we just made it invisible. So it'll be invisible quickly and then back up on the screen. And then finally, we're going to flip the play again button. So the play again button dot is hidden will then be set to false, because now if they want to play again, they should be able to play again. All right. And I'm just checking all the instructions in the book here. So I'm looking at all the instructions on page 590 and 591 in the teacher's edition. And I'm just, okay, so they're saying add a call to the method that you just created in the view did load function. So I got to make sure that those are included, because if they're not included, so like if we're not calling the stuff to run from the view did load, remember this is kind of like the main method in a Java program, nothing's going to happen, right? So I got to check that code file. So I'm switching over here where I got the master version of this that I'm copying from, by the way. And we're going to start by calling the update. And I don't want to be typing where I'm typing, and I apologize. I'm typing in my What I ended up doing is deleting my original code in my Visual Studio Code where I'm copying from. So here we want to call update UI, and what we want to feed to it is the fact that we are in start mode, right? So trigger back to start. The other thing that we also didn't do yet is we have the action outlets here set up for each one of those buttons, and we haven't put anything in there yet, so they're not going to do anything when we tap them. So we have to add a little bit of code here. So this is how this is going to look. So for rock, we're going to choose play. So whenever a person hits it, we're going to do a play, and then they have to choose rock. So which sign are they hitting? If they're hitting rock, or they're hitting rock, right? So the same thing will happen with paper. So if we come here and say play user sign, and this will be dot paper, and then here as well, we'll just keep playing on that example. And see, after a while, it learns what you're doing. A little too late, right, to help out significantly. So each one of those will just make sure that we're choosing the right sign as we're passing it through the game as we're tapping. And then we're going to do the same thing with play again. But play again, all play again is going to do is trigger start to happen, right? So we just go back to the beginning again. So here we're going to say not play. So I got to be careful there. We're just going to call the update UI thing again and go back to start mode is what's happening. All right, so I think, and I'm looking at all my code here, I think we have all the code input at this point. So I think we might be ready to give this a spin, but I'm checking against the book to make sure that we crossed all our T's and dotted all of our I's.
Quick question.
Yeah.
Maybe it might help. Is for the computer choice, where is the I guess the function that randomly picks the computer's choice? Is there a dot math random function that
Yeah,
needs to be in place?
if you remember, Jonathan, we did it here in the sign enum. We let that happen here as a function. And then when we hit the play button.
That's right. Yeah.
Yeah. Okay. When we hit the play button, and I'm trying to find where we put it here. So when we hit the start, okay, those are all the visual elements right here. So when we're playing, the first thing that happens is the computer runs the random sign function from the enum, right? Before you even tap the screen, it's already, well, actually, no, think about that. When you tap the screen, it triggers play, but the first thing it does is makes the computer pick randomly. Then it checks the game state basically with this function to see, what is your opponent's sign. And if it is the same as yours, it's a draw. And then, it basically returns this stuff here, and then it goes on to further process. Depending on what is selected from the game state, we update the user interface, which is this one that we created. So it comes up here and it looks for, first of all, the status, whether or not we won, right? And the status is declared here. These are the messages. So you could change those messages if you want. And then based upon that state, we then can do the following action. So once again, these are all visual things, like changing the background colors, hiding the buttons, and whatever. And then you basically kind of reverse that logic here to make it set up so that you can play again. All right, well, let's give this a shot and see if it works. There may have been something we've overlooked, but I guess we're going to find out by doing a build. So I'm doing the build, waiting for that simulator to load. And might be in the background here. It sure is. So there's the simulator up and running, waiting for the app to propagate. All right, so there it is with the gray background, the robot, and the three hands. And now we should be able to interact with it. So I'm going to just go with rock. All right, so I won because they chose scissors. Rock, break, scissors. We'll play again. I'm going to try paper. I lost, right? Because they have scissors and I have paper. We'll hit scissors. It's a draw, right? And, you know, whether or not it's going to hit all the possible scenarios is really kind of up to chance, basically, right? What I would suggest that you do, though, and this is normally what I say to my programming students when they're using something that's random, that's a possibility. One thing you can always do is you can override the randomness and just force a setting to make sure all the scenarios work. Otherwise, you're just going to keep clicking and trying until all the scenarios are covered. Right now, it does seem like it's working, though. Is it working for you guys also?
It does work for
My-
me, yeah.
My try again or play again doesn't work.
Okay. I'll tell you what, let me pause the recording here and then we'll take a quick look as to why.
Okay.
All right, so we've been having an issue with one of the students' code. And boy, you know, we've looked up and down and backwards and forward at every single code file. We did find one little typo, but it wasn't really one that was critical. But we're looking at this error in the console, and I'm going to draw on your screen here, by the way. So this little error here, it says view controller play again chosen unrecognized selector sent to instance. And now there's one spot where that's happening, and I'm going to take control of your screen if that's okay.
Go for it.
You gotta click the little button there. There we are. And basically what's going on is when we, and I don't know if I can control your screen as well as you can, I'm trying here. Right. Remote controlling somebody else's computer is always a weird thing. But basically when we were in here creating these outlets or actions, excuse me, right? And we're doing this as a pattern, right? A rock chosen, paper chosen, scissors chosen, and then play again. The natural instinct is chosen, and that's what you did. And then you realize that's not what it should be named, right?
Yeah.
And then you renamed it here, but the connection, and so this is how we can troubleshoot this. We'll click on the code here, like, or basically this connection, right? And I don't know if I can trigger that connection here at all. I'm trying to get it to pop up in the inspector panel, but it's just not doing it. And I think that may be the trick to that. Very hard to do this, by the way, on a remote control basis. Let's see if we can zoom in. Oh gosh, this is very challenging. But you can see right here now that I got the button selected that the connector is not correct.
Yeah.
So it's got the wrong name here. And no matter how much we do this, it's going to fail. You know, so what we're going to do is we're going to just remove it. All right.
Okay.
And then what we'll do is we'll recreate this little block of code. Now, what you could do is, if you want, and I'll do it for you, basically, is I'm going to do a cut on that so that I don't have to retype it, basically. And then I'm just simply just going to remove this, this whole thing. Just goodbye, right? And then I'm having a hard time zooming in on that, by the way. It just won't do it.
Let me try.
Yeah, if you don't mind, like, just zoom in on that if you could.
Oh gosh, let's see.
Yeah, and none of the tricks are working. You know what?
No.
It doesn't really matter because the button is selected right now.
Yeah.
So whatever, let's just kind of leave it there. And so what I'm going to do is I'm going to control drag now from that. Okay, and that's not we got to find a way to zoom in on that a little bit. Why don't you take your screen back and just zoom in?
Yeah, I'll try that.
I mean, you should still have mouse control. I'm taking my hands off the touchpad
Okay,
and the
let me
magic
turn
mouse
this
here.
off.
Um,
Like, let's see, where's that zoom button?
you should be, if you're on a touchpad, you should just be able to pinch
You know what?
to
I've
sort of. There you go. All right.
totally forgot about this.
Okay, that'll work. Just as long as we can have that button on the screen. And in fact, why don't I just coach you at this point rather than me doing it? So I'm going to stop the remote control. Go ahead and control drag back over to line 43 there. All right. And we're just going to say play again with a capital A. And all the rest of it's okay. Just say connect. And then inside the curly brackets, create a line and just do a paste. The code should be in your buffer. Okay. All right. I think we're good. Fingers
so.
crossed. Let's go ahead and hit that run button and see what happens here.
Does not like paper.
All right, let's take a look at the console. We are recording, by the way, so this should be interesting for people watching this. Let's go to the top of that error message. So let's see what it's. Okay, so now we have the same problem with paper chose because you misnamed it at first. So here's my suggestion is we could recreate it.
Yeah.
Right? We could create that IB action, or we could just switch the name back to paper chose.
Okay.
And just roll with it. And that's, I think that's probably the easier solution here. So let's go back to that view controller, just get rid of that N, right? So what this is showing you, and this is really an important takeaway for anybody, watching the video or for both of you guys here in the session today, is once you create an object like this and you link them up, there's back-end code that's getting generated that relies on how you did it the first time to be correct. Now you can see it's working just fine. Right. All right. So we did at least figure out the problem. So that was kind of a great troubleshooting skill, by the way, of going through that. If you wanted everything to be named equivalently, you could go in there and fix it, like recreate it, whatever. But at this point, it's working. I would step away, drop the mic or whatever you have to do, and just call it a day. Right. So let's say that this app is a successful build, and I'm going to go ahead and stop the recording here, you guys.
Okay.
So that was the rock, paper, scissors app, including troubleshooting problems in somebody else's code. But we got it to work, and that's what's important. All right, so we're all done here.